session. My name is Elina. I'm here to support Florian. If you have any questions, feel free to ask them at the end of the session. As you probably all know by now, I'm going to come to you with the microphone so that those at home hear you too. And for those at home, feel free to ask all your questions in the chat and I will read them out loud at the end. Thank you. Have fun.
So hello everyone, welcome here and welcome at home to Growing the PHP Core one test at a time. My name is Florian and I'm a PHP developer since quite some time now, and I'm working remotely, fully remote at a company called Raiffeisen Networld. We are building a B2B e-commerce platform for the agricultural sector in Germany. And besides that, I'm an open source contributor. The libraries I contribute to are mainly stuff that I use in my day-to-day life. So that be, for example, GraphQLite, PHP Unit, and the PHP Core itself. And I'm doing so although I'm married with 5 kids. So that being said, if you do not have at least 5 kids at home, I would assume that you will be able to find some time to contribute to open source. So I told you that I'm a PHP developer since quite some time. I started writing software in PHP in September 2000. That's 20 years from now. No, that's 21 years from now. And my entire professional career is based on PHP, with some exceptions in exchange for money. I also did some HTML, JavaScript, C, assembler and stuff. But I would say that 90% of the time in my career, I got paid to solve problems, and I solved them using PHP. And that means that my entire career is based on the fact that PHP exists, that people built it back then, and that still today people are building PHP. And that brings me to the question that I ask myself, that it's probably time to give something back to the community. So in 2017, I don't know exactly how, but in 2017 I stumbled onto the PHP Test Fest. The 2017 edition was the last one so far. It was organized by Ben Ramsey and Sammy K. Powers and some others, probably names you all heard in the PHP community. And the whole idea of the Test Fest was to bring people to write tests for PHP. This was in hindsight also the moment that I realized that PHP itself is also tested. And I found out that you don't need to actually write C code to write tests for PHP, because the tests for PHP are written in PHP. And so you don't, there was no need for me to create a new language feature, make an RFC, or create an extension, or anything else, or write C code at all, to be able to contribute somehow to PHP. And I'm here to tell you how you can do this too. So the first thing you got to do when you want to write tests for PHP, you need to compile PHP from source, because the tests itself are usually not included in the packages that you install via apt-get or yum or DNF or whatever. So what you're going to do is you can clone the PHP source code from GitHub. It's all there. I would advise you to create your fork before cloning, because I would assume that, including me, there's no one here who has push rights to the PHP source repository. Or is there anyone by chance? No. Okay, so you better create a fork, then clone. Then you run build conf, configure, make, and then you have your binary. And I would say I just show you, because I prepared that binary. Sadly, I cannot run configure and build conf and all these things, otherwise we would have to recompile. That would take roughly 10 minutes. And probably we do not want to sit here waiting for 10 minutes. So let me just switch. And so as you see, we have PHP 8.2 already. That's mainly because I compiled from master branch. PHP 8.1 is already branched away from the master branch. So what you get when you check out the master branch, you get PHP 8.2. And you see that I compiled it yesterday in the evening. OK, let's get back. So when you have compiled it, we have our binary, everything set up. We need to know how to run the tests. To run the tests, we basically just do this. There is a make file that does all of this for us and starts the test runner. And we can do that now. by just executing make test. If you would execute make test, it would run one test after the other, but you can give it an argument that specifies how many test run it should use. That's -j. And the nproc is just a tool that returns how many CPU cores you have in your laptop. So if you run that, we see a lot of stuff scrolling by, and in the first column you hopefully see a lot of pauses. There might also be some skips and fails and warnings, but we'll see about that later. In the lower left corner you see the number of concurrent test workers that's running and the number of tests that are executed. You can imagine that if you run just one test after the other, it takes a lot longer than having 8 concurrent test workers running. The more CPUs you have, the more parallel this would be executed. So let's just wait for it, and after it we see some summary. In the end, the last few tests that have been executed are tests that cannot be run in parallel because they have side effects. So let's scroll a bit up and see what we have as a test result summary. So the test result summary is that we have 45 extensions skipped, 27 extensions have been tested. Overall, there is 7,008 tests in the entire PHP repository, of which we execute only 11,891. Then you have those tests skipped, test once, failed, expected fail. Overall, I would say we have 99.7% of tests succeeded. And the best thing, or what I really like about it, is that when running 8 concurrent test workers, those 11,800 tests are executed in roughly 35 seconds. So what we also get is we get an overview of the expected failures. So there are tests that are expected to fail, and they're still run. Then they fail, but was expected. But you get them in this list at the end. Usually there is a reason why tests fail, and usually the reason is a link to some forum or the internals mailing list or something else where it's discussed why it's currently expected that the test fails. Then we have 2 fail tests. So for some reason those 2 tests fail. Somebody should look after that. And then there is a warning. This warning is particularly interesting because it's a warning about a seg fault in far. And the warning is because it was expected this test to fail, but the test did not fail. So now that we have this, so now we can run the tests, and we basically see that like 99.7% we are green. So now let's have a look at how such a test actually looks. Test files in PHP are basically ASCII files. Divided in sections. So you have a few sections here. For example, let's start with the test section. The test section is just a simple name of what you're going to test. And it will be printed out by the test runner. So what we seen scrolling through, these sees just the whatever you write there in test. If you want to write more about the test, what it does, there is a description section that I have seen nowhere, but it's there. Then we have seen that some extensions have been skipped, so tests were not executed for those sections, extensions. That's because the test can mention in the extension section what extensions have to be compiled in order to run this test. It makes no sense to execute a test for an extension that's not compiled because it would fail anyway. Then there is the skip-if section. The skip-if section is, as well as the extension section, not mandatory, it's optional. Skip-if section is just that you have some PHP code that you can execute and decide that to skip the test. So in this case, this makes no sense. The core extension is here, or we have the dependency in the core extension already specified, so the string-lang function that we should be there. If the string-lang function is not there when the core extension is loaded, then we have another problem. The skip-if section works basically like the following. The test runner will execute the code, and when the output will start with skip, then it will skip the test and count it as skipped. The next section that we have is the actual test then already. That's the file section. So what happens is the test runner will execute whatever you have in the file section and will match the output against the contents of the expect section. So in this case, it will execute this var string lang hello world, and we expect the output to be int 12. If it matches exactly, then the test passes. If it doesn't match, it will not pass. It will fail. Alternatively, if you need to use, in some cases, you need to use substitution tags in the expect section, you can use expectf. When you have an expectf section, you can use the substitution tags that you know from printf. So you could alternatively write an expectf section here with int and then %d. So it would allow any number. That would technically the test would succeed, but it would render the test useless. And then you have a clean section. The clean section is just here to clean up after yourself. So if you have any files left or any side cases laying around, you can clean that up. One thing you need to know additionally to that is that also all those sections that you have here are executed in isolation. So there is, if you declare, for example, a variable in the file section with a path to a temporary file, that variable will not exist anymore in the clean section because it's another PHP process that executes the clean section, the file section, and the skipif section. So now that we know how a test looks like, the question is, what do we test? So what you can do is you can head over to the Azure pipelines. That's where the tests for PHP run. And for every scheduled build that PHP runs for the main branches, so that's currently for PHP 7.4, 8.0, 8.1, and for the master branch, a code coverage report is generated, and you can head over to the code coverage report. When I started writing tests for PHP, all those things have been posted to gcov.php.net, which was basically the page to look for the code coverage report for PHP. But that one is retired since of PHP 7.4. So when I head over there, I found this. So this is in the setlib extension, a small function, a PHP function called setlib get coding type. And I've seen this and thought to myself, this is pretty easy because it's just a switch statement on a variable that might return 3 different values, a string gzip or string deflate, or it might return false. That's all it does, so it looks super simple. And okay, so first of all, I had to look out what this function actually does, like what's the bigger picture for the function. And you can do that by looking at the source code, or you can consult the documentation. The source code we have here, and let's have a look at the documentation. You can just go over to php.net/setlib-get-coding-type, and what it actually does is the following. So PHP can do magic output compression for you. So that means when an HTTP request arrives at the server and the client stated in the HTTP accept encoding header that it, for example, accepts gzip or deflate compression, and you have an ini setting turned on that you actually allow PHP to do magic output compression for you, PHP will actually then compress the output stream. Okay, so now we have this information. We found out about gzip, deflate, about the HTTP accept encoding header. We need to set up an idea of what we want to test. So basically, we need to write, in order to test this function, we need to write tests for the absence of an accept encoding header, the accept encoding header being gzip or deflate or anything else that we do not understand currently. And we also need to keep in mind the setlib output compression ini setting. That's the setting that you can turn on and off to actually allow PHP to do magic output compression. And I would say we go through what I've been through and do some coding. So one thing is I prepared a test for us. This one. So what we do here is we have a test section and basically specify what we do. So what we're doing is we are testing the setlib get coding type with the gzip encoding. We are depending on the setlib extension. When the setlib extension is uninstalled, we don't need to execute this test. And then we have a file block, which is the actual thing that we are doing. So what we are doing here, we know we need to set the HTTP accept encoding somehow. And we know that we can access the HTTP request parameters in the $_server superglobal. So in this case, we are just writing the string gzip to HTTP accept encoding. Then we can set the setlib output compression to off. And I would say when we then call setlib get coding type, it should return false. because the client specified that it accepts gzip, but we don't do output compression, so PHP shouldn't do it. And when we activate setlib output compression, setlib coding type should actually return gzip, at least hopefully. And then we create an expect section, and we have the first output of vardump from line 9 that should be bool false. And the vardump in line 11, we expect it to be string 4 with the value gzip. And you don't need to execute the entire test framework anymore, but you can run single tests with, be with me while I find it, this command. If you just run make test, it will execute one test at a time. You can give it arguments. And one of those arguments is the tests argument, where you can give it a folder or directly a file name to be executed. So all we need to do is hit enter, and then we run the tests. Okay. So we executed one test. Number of tests 1 and one test has been executed, and we see that it failed. That's too bad. But the good thing here is it failed pretty fast. So one thing the test runner does for us when a test fails is it leaves all the temporary files laying around that it had. And one of those files that's interesting in this case is the log file that we have. The log file states the expected output, whatever we expected from the test to actually do for us, and then the actual output. And the actual output, we see that our first assumption, the Boolean false, actually went well, but the second assumption didn't because we have a warning created. And the warning is that we cannot change, or we are not allowed to change the setlib output compression ini setting when headers have already been sent. And that actually makes sense when you think about it, because what happens is the following. When PHP does output compression for us, or if it doesn't do it, doesn't matter. When PHP starts sending out the output to the client, the HTTP response header will also be sent out, and it will be indicating to the client if the body that comes is compressed or not, and if it's compressed, if it's gzip deflate or whatever. So with the first bool false that we send out, the HTTP headers have also been sent out, indicating to the client that we are not doing output compression. So we shouldn't change this because the client wouldn't be able to understand anymore what we send them. So this makes sense. And we can change that pretty easy. So in this case, I would say for the, we just store this in a variable. And this one too, just for the sake of it. And now we haven't done any output before we do the second call to the ini-set. Let's just add the vardump. Oh no, it's the other way around. Looks correct, right? First call to setlib coding type, then ini setting on, then second call, then we vardump out. The off we expect false, and for the on we expect gzip. So let's run it again and see if we are lucky this time. And still not lucky, but we know we can have a look at the log file. And this is particularly interesting because it just doesn't work. So we have the expected bool false. The first one is still there. The warning is gone. That's good, but I would have hoped that the second variable is now string gzip, but it's not. So let's have a look at the test again. This is super interesting because I would assume that this actually works. We have the HTTP accepting coding header set. The usual things you go through, check if you misspelled something, but it's all correct. So what can you do? There's a few things you can do. You can look at the source code. I would say we do that. I would say we have a quick glimpse at the source code to see if we actually find out something about it. So when we search for the, where do we have the function? Let's just skip through it. Setlib get coding type. Here we have it. So that's the setlib get coding type function that we are trying to write a test on, and we see it's still in PHP 8.2. It's still the same. It's just a switch on the compression coding variable. returning gzip deflate or false. So somewhere in this code, there need to be an assignment to the compression coding, and this is where the fun begins. Let's look for that one. Where is an assignment? Oh, here we have an assignment. Okay, so there's a C function called PHP setup output encoding, and it somehow is the only part in that file that does that writes to the compression coding variable that we are switching on in our function that we want to test. And I started to dig in this if statement here, and actually, to tell you the truth, I have no idea what this line does. It looks like it's checking if the track var server, whatever that is an array. But the other thing that I actually understood is that one. This send hash string find. So basically, arrays in PHP, or a concept of an associative array on machine level doesn't exist. So what PHP does for us, it creates a hash map for us. So we have the nice shiny interface of an associative array, but under the hood, PHP has a hash map for us. And what it does here is, you can see that it tries to find the HTTP accept encoding key in something that's HTTP global's track var server, and whatever the value is should then be in the enc variable. And then it does a convert to string, and then it does an if statement if that's gzip, and then assigns gzip to it. And I would assume that track var server is actually what we in user space or in the PHP land have then as $_server available. And this is actually true, but the point is, this proves that my test is correct, but the test is still not working, so there's something else playing with us. So the alternative that you have is, the second thing, you can head over, as I did, to phpc.chat, where you find a lot of people from the PHP community. And then you can ask them what's actually going on, because you did everything correct. And they state you a very interesting thing. If you're a bit into memory management in PHP, then you know that PHP actually has a copy and write mechanism. So every time you call a function, you give it basically a reference, and as soon as you start writing to that variable, PHP will create a copy for you. And the exact same mechanism is also true for all these super global autos. The same mechanism is also true for all the super global autos that you have. So $_server, $get, post, and whatever you have, all those variables are copy on write. That means as soon as you write to them, PHP creates a copy for you in user space to work on, and the PHP core itself still has the unaltered original. And that's why we cannot alter the value from in our test. And if you think about it, it totally makes sense, because when the client states to us that it is able to understand gzip encoding, and we in our source code then decide, oh no, you understand no deflate, and PHP would do magic output compression and send a deflate compressed output stream, the client had no chance to understand what we sent it. So this would mean that, this could mean that there is a sad end, because we cannot actually change the value from in our test. But when you have a look at the documentation on the PHP file format, there is another section that comes in handy here, and that's the env section. So what we can do is we can actually inject environment variables from the outside. And this is what we're gonna do now. We inject the HTTP accept encoding, gzip, as an environment variable into the PHP process that then executes the test. And let's try it out and see if it works now. Oh, and it still failed, come on. Let's have a look at the log file and see what's going on. Okay, that actual output is not expected. Super cryptic binary stuff. Whatever that is, let's have a look again at our test. So what do? We tell PHP that we understand gzip output encoding. Then we turn it off, then call select encoding type, then we turn it on, then call select encoding type, and then we output something. So one of the things that actually happens here is the following. We tell PHP that we accept gzip as an output encoding, and we turn it on. So what does PHP do? It does a gzip encoding for us. So what we get is basically a gzip compressed output stream that we can't read. But just to make it easy, we can just turn it off again. And hopefully the test passes now. And we see, final success, the test has passed. So just a small recap, this is the test that you can actually find in the PHP repository. There is also a test for HTTP accept encoding being deflate. There is a test for no environment variables, so no HTTP accept encoding being set at all. And additionally to that, one test with HTTP accept encoding being set to just some string that the setlib extension does not understand. So what did I do? I created a pull request to PHP source, and the pull request got accepted. And in PHP 7.3, the GCAF page finally showed code coverage for that. And that's actually a nice feeling. So what did I learn? First of all, the usual things. I thought that it's super easy. It's just a switch statement, nothing too complex. You can do this. But actually, it was way more complex than this. I learned about that the copy and write mechanism is also true for superglobals in PHP, which makes sense, but I haven't thought about that. And that there are modify handlers for ini settings. So basically, every time you call iniset and give it a variable that you want to change, in most of the cases, it's not that it's just a variable that's been set in PHP, but there is a C function being called that checks if you're actually allowed to change the value to the ini setting to the desired value. And that will fail and raise a warning in case you're not allowed to, and the iniset function will also return false. So I'm not very often calling iniset, but now that I know that, I actually check on the return value on iniset. The other thing is, what do you gain? So when you think, what's in for me, like when I start writing PHP, test for PHP. So what's in for you is, first of all, PHP will be more stable and more reliable. Things that have been tested will not just flip in the next version and nobody noticed that it does. And I would say that's a good thing. And the other thing is, you learn a lot on the way about how PHP works internally. You learn about the copy and write mechanism, about how PHP does memory management. You learn about those ini setting stuff. And you learn a lot about the macro hell that you have in PHP, a lot of C macros that call other macros, and so on and so on. And for instance, what I learned, also not something just internally, but about an extension in PHP, is like in 2007 or 2008 was the last time that I had to work with zip files in PHP, and because there was nothing around, I decided to build a class and wrap the calls to the zip and unzip binary. It's a horrible, horrible thing to do, and I'm not proud of it. But I found out that there is a zip archive class where tests were missing, so I added some tests, and a few months later, I had a task on the board that we need to handle zip files, and I actually knew that I could use the zip archive class and don't have to wrap calls to zip and unzip binary anymore. And the other thing is the PHP test format. If you learn that, if you learn how to write tests with the PHP test format, it's not that it's just been used in PHP itself, but PHP unit has a test runner for the PHP file format. That's the one thing. And the other thing is PHP unit itself has a lot of tests, a lot of stuff in PHP unit is tested with PHP files. So if you learn the PHP file format, you can actually start writing tests for PHP unit also, and that's how I became a PHP unit contributor. And the other thing that you gain if you start writing tests for PHP, contribute them, and the pull request is actually accepted, you can tell everyone, if they want to hear it or not, that you are a PHP core contributor. That's all, folks. Thank you very much for attending. And if you're further in this topic, there is phptestfest.org. It's a bit outdated, but it's still true, everything there. There's qa.php.net, where you have the quality assurance about PHP. There you have all the documentation, also the documentation about the PHP file format and all the extensions that there are. There are quite some more. And at .box.org, which is my blog, you can find a blog post with the exact same topic. And additionally to the talk, there is a section about how you can create your own code coverage report locally. Because when I did my contribution, I didn't run a code coverage report, and I was happy to see that it actually covers the lines. Thank you very much.
Okay, are there any questions in the room? Because there are no in the chat. Well, I check one more time. No. No one? Okay, then as you know, you can contact him afterwards. And I think then that's the end of the session. Thank you. And now there's a half an hour pause.
Thank you very much.